Hello guys, welcome to Self-Help Maths Academy. Today we are going to discuss the next part of the linear transformation, that is kernel and range of a transformation. Let's see what is the kernel. The kernel of a t is denoted by kernel of t like this is the set of all the vectors that map to 0. What do you mean by this? So that means suppose in the notation we can write this as x is any vector belongs to V, where t is a transformation from V to W, right? Such that my image of x, that is t of x, it should it should map to 0. So all the x's belongs to V. If t of x is mapping to 0, that is defined as kernel of t. Okay, that is called as the kernel of t. Okay, now let us see, let us understand this particular concept with the help of example. So here, let t is the transformation from R2 to R2 be defined by, it is defined by say t of xy. Okay, this is equal to say x plus y and 2x plus 2y. This is how they have defined. We have to find the kernel of t. Find the kernel of t. Let's see how do we do it. So here we are looking for the vector xy. Here what is the meaning of that? As per the definition, we should look for the vector x such a way that whose image who maps to 0. Okay, that means we are looking for the vector say x y, since it is in R2, so xy belongs to R2 such that that's image, the vector's image xy should be equal to 0 0. Okay, but what is our t of xy? It is given that t of xy, this is equal to x plus y and 2x plus 2y. So this should be equal to what? 0 0. So equate these two. Now because these are the matrices, if they are of the same order we can equate them. Therefore this gives that x plus y equal to 0 and 2x plus 2y equal to 0, right? So that means what, from the one, if you see x is equal to negative y, we got. Note that the second equation is twice the first equation, so therefore they are dependent, right? So therefore from the first equation, if we see the second equation, it is 2 times of the first equations, hence I'm not taking the second equation anymore. So therefore x equal to negative y. So therefore if I write a solution, therefore my kernel of t will be that x means here it is your x and y, but what is your x is equal to? It is negative y is y only. So therefore this one, such that y is any real number. Okay, so therefore if you see, if I take this y out here, so it is simply negative 1 1. So therefore it is simply what? Span of the vector negative 1 1. So this is our kernel of t. This is our kernel of t. This vector goes to 0. That's the meaning. If you put x and y as negative 1 and plus 1, if you check, if I put x as negative 1 in this case, put it in this equation, if x is negative 1 and y is 1, it is 0. If x is negative 1 and y is positive 1, it is still 0. So that means it is satisfied. So it maps to 0 0. Okay, so that's the meaning. So now let us see another example. If let t is a transformation from R3 to R2 be defined by say t of x y z, this is equal to, this is defined as x plus y plus z, x minus y plus z. Okay, now we have to find the kernel of t. Find the kernel of t. Let us continue. So what we want we are looking for the vectors. We want all the vectors, say x, y, z, which is in R3, such that our T of x, y, z is equal to what? 0, 0, because it is from R3 to R2, right? But what is our T of x, y, z? It is defined as x plus y plus z, because this is our T of x, y, z. It is defined as, this is x minus y plus z. This is equal to 0, 0. Okay. Now this one, this yields the system. This yields the system x plus y plus z equal to 0, x minus y plus z equal to 0. Okay. So let us take this as 1, let us take this as 2. Okay. So now what we do, we try to subtract 1 from 2. Let us subtract 1 from 2. Subtract 1 from 2. So it is x minus y plus z minus x plus y plus z. What we get here, we'll try to see. I think I can cancel x with the x, and minus z plus z minus y, that will be minus 2y, right? So this is equal to, if and on the right hand side it is 0, so therefore it is minus 2y equal to 0, implies y equal to 0. Okay. So once I got y equal to 0, substituting y equal to 0 in 1, substituting y equal to 0 in 1, what we get? X plus 0 plus z equal to 0 implies x equal to negative z. Okay. So therefore the kernel of t is, that is, should be x, y, z, right? But what is our x? X is negative z, y is 0, and z is z only. So if I take z out, it is simply negative 1, 0, 1. So therefore you can see that it is simply span of negative 1, 0, 1. So this is our kernel of t. This is the kernel of t. Okay. Yeah. Let us see another example so that you will become familiar with the problems. Okay. This example, let t is the function from R2 to R. This is defined by t of x, y is equal to 4x minus 2y. So find kernel of t. Okay. So let's see this. Here what happens, our function is defined from R2 to R. So we need the vector x, y belongs to R2 such that t of x, y is equal to 0, right? So that's how it is defined. So what is our t of x, y is defined as? It is 4x minus 2y equal to 0. That's how it is defined. So therefore 4x is equal to 2y, dividing both the side with say 4, x is equal to 1 by 2 y. So here we get 2x is equal to y, or x is equal to 1 by 2y, anything is fine. So now finally when you want to write the kernel of t, which is say t of x, y. Okay, so this is equal to x, y, that is, what is my x, y here? If you see, our x is x and y I'm taking it as 2x. So if I take x out, it is 1, 2. So simply span of say 1, 2. So this is our kernel of t. Okay. This is another example with respect to the kernel. Okay. Now let us see another example. Let me take another example where let t is a function from R3 to R3 be defined by a matrix multiplication, say t of x equal to ax, this is equal to 1 0 negative 1 0 1 negative 1 and then 0 0 0. Okay, so find the kernel of t. Find the kernel of t. Okay, so let's continue with the solution. So here we want the x such that let x is x y z, because it is from R3 to R3. Then our a into x, if I multiply this is my x and this is our a. What is our a into x will be if I multiply this with, let me say, this is a 1 0 negative 1 0 1 negative 1 0 0 0 into, say, x y z is equal to, it is x minus z and then y minus z, this is 0. Okay, so therefore we want what, as per the definition, t of x should be equal to 0, which is t of x is ax here. So therefore we want ax should be equal to 0. Okay, that is, what is our ax here? By the definition, it is x minus z, y minus z and 0. This should be equal to 0, right? So therefore 0 0 0. So this implies x minus z equal to 0 implies x equal to z, y minus z equal to 0 implies y equal to z, and z is z, so that is free. 0 equal to 0, 0 equal to 0 implies z is free. So therefore if I write a solution, x y is z, this is equal to, what is our x is z, y is z and z is z. So if I take z out, so this is simply 1 1 1. So hence the kernel of t is span of 1 1 1. Okay, so this is our kernel of t. All right, so in this type of examples where the matrix is given to us and they have defined t of x is equal to ax, we will follow this method. Okay, and then let us take another example. I think I'll give you one example for yourself, so please give me the solution. All right, what is the kernel of t? So here let t is a transformation from R2 to R2, be the identity transformation, that is t of x y equal to x y. This is how it is defined. We have to find the kernel of t. So give me the solution, guys, in the comment box. Okay, so this is solution, you can try. So let me now discuss the range. What is range? So the range of t, the range of the transformation, the range of a t is denoted as, say, im of t, that is the image of t is the set of all vectors expressible as t of x. Okay, so let me write that as image of t is nothing but y belongs to w. As you know, your transformation t is from v to w, so here we are considering your y is belongs to this w, such that your y is equal to t of x, where y is the image of x in t, right? For some x belongs to v. So this is how we define our range. So it is basically the image of all the elements of x, okay, in w, right? So let us see the examples. Try to understand this definition with the help of example. Now let t is a function from R2 to R2 be defined by t of x y. This is equal to, say, x plus y and 2x plus 2y. Okay, find the range. Find the range, or also sometimes they ask you like this. Okay, so that is at range, you should understand. Let us see now what we want. We want some element. Let me take some vectors. Say v is equal to xy in v, then I want t of v. So I want t of v, that is t of v is given as here x plus y, 2x plus 2y. This is how it is given. Okay, so this is equal to, what I can do here, I can take our x plus y common from both the side. If I get that, it is 1 2. So all the images here, so all the images, so all the images that are the scalar multiple of 1 2 will be the kernel of t. Okay, sorry, the images, so all the images are the scalar multiple of 1 by 2. So therefore the image of t will be span of these vectors. So all the vectors which are scalar multiple of this vector 1 2 will be the image of t. Okay, let's see another example. Here, let t is the function transformation from R3 to R2. It is defined by t of x, y, z. This is equal to, say, x plus y plus z and x minus y plus z. Okay, now find the image. Find the image of t. So here, as we know that this is a 3 cross 3 matrix. So what we'll try to write is, we'll try to write our vectors in the standard form. Okay, so now solution, let us write t of x in terms of standard vectors. So standard vectors are in R2, in R3 it is E1, E2, E3. That is, say, E1 equal to 1 0 0, E2 is 0 1 0, and E3 is 0 0 1. So these are the standard bases, okay, of the vector t of x. Now, so let us compute t of E1. So as you know that it is R3 to R2. If it is x, y, z, this is how we define. This is our x plus y plus z, x minus y plus z. Now here t of E1. So t of E1 means what we will get. This is x plus y plus z. So x plus y plus z means you will be having here 1 plus 0 plus 0. And the second one is x minus y plus z. It is 1 again. Okay. So t of E2 is again. So this is x is 0. Y is 1. So it is 1 here. Since y is negative, so y is negative here. So t of E3 is 1 1. Okay, so this is our t of E1, t of E2, t of E3. So now here one thing we have to note. If you see t of E3 and t of E1, they are same, right? So it's not linearly independent. So they are same, they are linearly dependent. So it's not linearly independent, they are linearly dependent. Okay, so they are one another same. So now we have to consider the span of the distinct vectors. So consider the span of distinct vector. Okay, distinct vectors. What are the distinct vectors? Either you can take t of E1 and this one, or you can take t of E2 and t of E3. So let me take now any one of them. So therefore the image of t will be span of the distinct vectors. So distinct vector is you can take 1 1 and 1 negative 1. Okay, so this is the, so check if they are linearly independent. If you want, you can just check them. So here, for checking if they are linearly independent, how do we do it? A into 1 1 plus b into 1 negative 1. Let me take this as 0 0. I should not get a and b as 0. So that's how it should be checked. Then this is a minus b equal to 0. So I mean, like I should get, if they are linearly independent means a and b equal to 0 is the only solution, right? So just subtract this. What I'll get here, 2a equal to 0 implies a equal to 0. If I put a equal to 0 in the first equation, you will also get b equal to 0. So a equal to 0, b equal to 0 is a trivial solution. So therefore the vectors are linearly independent. They are linearly independent. So therefore image of t is R2. Image of t is R2. Okay, so that's how it is. You need to find it out, right? So let us take another example for the image. Let t is a function from R2 to R be defined by t of xy is equal to 4x minus 2y. Then we have to find image of t. Okay, so here if you see, this is a linear combination of the inputs, right? If you see, it's a linear combination of the inputs. So therefore the output is always a real number. If you see, this is if x is any real number, y is any real number, this will be giving us any real number. Okay, so therefore the transformation maps to a scalar. So let me write here, this is a linear combination of inputs. So as I give x and y inputs, it will give me a linear combination of x and y. So therefore it's a linear combination of the inputs. Therefore the output is always a real number. Output is always a real number. So the transformation maps to linear to a scalar. You can say a linear, or it is mapping to a scalar number. So since x and y are real numbers in scalars, any real number that can be produced by choosing x and y, that has to be produced, for example, the real number. So therefore what I do is, let me choose my y equal to 0. Okay, then so if for instance if I take y equal to 0, then our equation like t of xy, that is t of xy will be defined as 4x minus 2y, right? So this will be now 4x. Okay, because 2y, that will be 0, right? That way. Now if you see, I mean in the way, if I write it as in terms of a, right, then what I'll get, your x will be equal to, I mean if I put a equal to 0, then let me write x as say xy, or if you take this as a solution, then it looks like your x as your y is 0, which is free. If I consider if y is 0 and this x is, you're getting, that is like x by 4. So if I take x out here, so 1 by 4 0. So it is basically what we are getting the scalars. It is taking all the real line as its image. So it will take the whole real number. I told you x and y are any real number, so it will give me the real number here. So it goes to a real line. So hence our image will be, the image of t will be the whole real line. The image of t will be the whole real line. That is the basic understanding. Please. So I think like this you'll be finding out the image of the t. So image of the t, we can solve the examples like this for finding the range or the image. I think let me give you some examples. You can practice them and post the answers in the comments. Let t is a transformation from R2 to R2 be the 0 transformation, that is t of xy equal to 0 0. Then find find the image of t. Okay, so this is the example for you. Please solve this and let me know the answer in the comments. Okay, then with this let me conclude today's discussion. We will see the next concept in the next video. Till then, take care, guys.